Good day, everyone. We're Group 4 from Cluster F Chemistry, and today we're excited to talk to you about clean fuels, specifically green hydrogen. Now, we all know that for many years, the world has relied heavily on fossil fuels, but every time we burn them, we release carbon dioxide, a greenhouse gas that traps heat in our atmosphere, which is one of the reasons why global warming is happening. Why does that matter? Well, going beyond 1.5 degrees Celsius puts us at greater risk of serious problems, like rising sea levels, extreme weather storms, biodiversity loss, species extinction, food scarcity, worsening health, and poverty for millions of people all over the world. According to the Intergovernmental Panel on Climate Change, the biggest reason our planet is warming up is because of fossil fuel emissions. In fact, back in 2018, about 89% of global carbon dioxide emissions came from industry and fossil fuels alone. So, what solution can we have for all this? Well, our group is here to introduce a solution, which is green hydrogen. Green hydrogen is a promising technology that's been gaining a lot of attention in recent years as a potential solution to the challenges of transitioning to a sustainable energy future. So what exactly is it? The concept of green hydrogen refers to the process of producing hydrogen gas through electrolysis using renewable energy sources such as solar, wind, or hydroelectric power. Unlike the conventional method of producing hydrogen from natural gas, green hydrogen is considered an environmentally friendly and sustainable option as it emits no greenhouse gases during its production and use. Now let's dive a little deeper into what hydrogen actually is, and more specifically, what green hydrogen means. Did you know that hydrogen comes in different colors? Take a look at this image to learn more about the different hydrogen colors and what they mean. Now let's focus more on green hydrogen. Green hydrogen is made through a process called electrolysis, which involves the separation of water molecules into their constituent hydrogen and oxygen atoms using electricity. In addition, when the electricity used in the process is generated from renewable sources such as wind or solar power, the resulting hydrogen is known as green hydrogen. Take a look at the diagram here.
This diagram shows how green hydrogen is produced. As mentioned earlier, this is done through electrolysis, and by first using renewable energy sources to generate electricity. This electricity is then used in an electrolyzer, which splits the water running through it into hydrogen and oxygen. The hydrogen gas resultant is then compressed and stored to be used whenever it is needed.
So, why green hydrogen? Here are the reasons. First of all, it's made through electrolysis, which involves the separation of water molecules into their constituent hydrogen and oxygen atoms using electricity. And adding to that, electricity can come from renewable sources like solar power and hydroelectric energy, which means it's not only clean, but it's also sustainable. Compared to traditional fuels, combustion hydrogen is actually safer. It doesn't release harmful pollutants, and under controlled conditions, it's considered a lower risk fuel. Another thing is that green hydrogen production can be decentralized, allowing for localized energy production and reduced dependence on centralized energy infrastructure. It's also incredibly versatile. Green hydrogen can be used in transportation, industry, power generation, and even heating. With this, it has great potential for sector integration. And as the cost of renewable energy keeps dropping, green hydrogen is becoming more affordable too. That makes it not just clean, but also competitive. Now, the Philippines faces rising energy demand driven by rapid population growth. Despite strong potential in geothermal, wind, and hydropower, the country remains heavily reliant on imported fossil fuels. The industrial sector is a major source of greenhouse gas emissions, especially from metal production, chemical manufacturing, and petroleum refining. These industries currently depend on hydrogen made from fossil fuels. Now, clean hydrogen offers a solution. It can help decarbonize heavy industry, reduce fossil fuel dependence, improve energy security, and support local economic development. The Philippines is part of the UNIDO Global Clean Hydrogen Program, funded by the Global Environment Facility. This project aims to build institutional capacity, strengthen policies, and enhance technology readiness for clean hydrogen adoption. It supports the country's net zero targets while ensuring social and economic benefits. Clean hydrogen is an opportunity for a more sustainable, more secure, and more resilient energy future for the Philippines. Now, green hydrogen offers huge potential, but there are still key challenges. Production costs remain high, technologies are still developing, and strong policy support is needed. Despite these hurdles, costs are expected to drop by up to 80% by 2030, making green hydrogen more competitive with fossil fuels. With growing global investment, green hydrogen is set to play a vital role in reaching decarbonization goals. Green hydrogen is set to play a major role in the global push for decarbonization. By 2050, it could help reduce up to 7 gigatons of CO2 annually, around 20% of human-driven emissions, if current trends continue. Its versatility makes it ideal for hard-to-abate sectors like steelmaking, ammonia production, long-haul transport, shipping, aviation, and building heating. It also supports long-term energy storage and grid stability. Production costs, while high today, are expected to fall by up to 80% by 2030 due to technological advances and economies of scale. In regions with abundant renewables, costs could drop to as low as €1 to €1.5 per kilogram by 2050. The market is growing rapidly. Valued at $5.6 billion in 2023, the global green hydrogen market is projected to reach over $60 billion by 2030 and potentially $1.2 trillion by 2050. Over 680 large-scale hydrogen projects have been announced worldwide, totaling $240 billion in investments. Europe leads the way, followed by major developments in China and across Asia. Green hydrogen is not just a clean fuel, it's a cornerstone of the net zero future.